Welcome, student. Today, my topic of discussion is Turing machine. And as you know, that this Turing machine is named over the name of our great Alan Turing. Okay. And in my previous video, we have discussed about PDA, push down automata, and in this video, I will explain you what is Turing machine and how it will work. And this is basically a very basic information and explanation of Turing machine. And if you want to know that how a Turing machine can be applied or the application of Turing machine, so you should go to my next video, which is based on the application of Turing machine. Now, here I am going to explain you that what is a Turing machine. Okay, so this Turing machine is basically it is made of using 7 tuples, and basically they are those 7 tuples are q, sigma, gamma, delta, q0, b, and f. Okay, so this capital Q belongs to finite non-empty set of states. Okay, and this gamma is basically a finite non-empty set of tape symbols. Okay, and your uh, sigma, basically this sigma is basically your finite tape symbols, or rather than you say them as input symbols. Okay, so input symbols and input symbols and this blank means the b is basically a blank which belongs to gamma. Okay, so all the input symbols you have, that is your sigma, and along with the blank input symbols, that is b, if you do the union of these two, so you will get this gamma. Okay, so is that clear? That means all the input symbols, that is your sigma, and this blank input symbol b, if we union them together, we will get this gamma. Okay, now other things, that is basically your delta is basically the transition function. q0 is the initial state. So here is your sigma, and sigma is a non-empty set of input symbols. And one thing is very important, that this blank, this b is you can see that this b is mentioned here separately, and also b is a separate tuple. If you see in the tuple set where we have 7 number of tuples for the Turing machine, you can see here that you have these 7 number of tuples where b is mentioned separately. Why? Because this b actually it does not belongs to the set sigma. Okay, so as you are seeing here that this b does not belong to the set sigma and b all together, they will form the gamma. Okay, but this b definitely it is a input symbol but does not belongs to sigma. Okay, so it's a special kind of input symbol. So your uh, sigma is a non-empty set of input symbols and is a subset of gamma, because you know that gamma minus blank is basically your sigma. Okay, now your transition function. Okay, and this is basically the delta is your transition function, and that maps q is the state. Then you have this x, your input symbol. So if you apply this q on x, will go to another q. Okay, and the x may be changed to y or may remain same, But the most interesting part is this D, okay, which you don't have previous in PDA. We have a stack symbol over there, but here we have this D. D, it denotes for the direction, okay. So when we go for the ID move, when we go for the ID move, so either we are going towards the right or we are going towards the left. This will be denoted by this D, okay. Now, this so basically it is D. It will denotes the direction of the movement of the read write head. Okay, so it will denotes the direction of the movement of the read write head. That means the read write head, it is moving towards left or it is moving towards the right. Okay, we can denote this by D. Now your Q0, and definitely that Q0 is the initial state and belongs to the capital set Q, okay, and F is the subset of Q, and that is basically is another set, and there is a set of final states. Okay, clear? Now we will see some examples how this can be written, how these transition functions can be written. So you can see here clearly that by this transition function, what we able to understand, that is, if we apply x, if we apply this x upon q0, so we will go to q2. Okay, the state change occur and it become q1 to q2, and this x remain x, and where the movement is happen towards the left side. Okay, and similarly for the next one, suppose if we have a Q2 and we apply A upon Q2 and we have applied A upon Q2, so what will happen? The state change occur and this Q2 become Q1, and this A will be replaced by this Y, okay, and the movement is towards the right direction of U. If you are sitting in front of this problem, okay, so definitely right is definitely towards your this direction. This is basically towards right, okay. Eh? This is basically your right direction, and if it is left, so definitely it is in this direction. Okay, now, so in next part we will see one example. We will see one example of Turing machine where we have a transition table, where in the table all the transition functions are present and mentioned, and we will see the movement and we'll draw the computation sequence of the input string 00, okay, for the above Turing machine. So now, definitely, what our initial state is what? Our initial state is Q1, okay, and we have the string 00, okay. So how it can be written? It can be written that, see, our start state is Q1, okay. So we have a Q1, and then we need to apply those 00. So these two are the input symbols, okay. Now if we apply 0, now if we apply 0, and you know that the ID move is denoted by this symbol, so we apply 0 upon q1, you can see over this table that when 0 can be applied upon q1, the 0 remains 0, q1 remains q1, and the movement is towards the right side. Okay, so that means this 0 remains 0 and right side means, so now this q1 comes here and we have another 0. So by this way you can see that movement of q1 is done towards the right. Okay, so that means it is also clear that what movement we are talking about. We're talking about the movement of the state. Okay, and also if you see in the above table, it is clearly understandable by all of you that here what happened, you can see that here all the transition functions or all the entry in the transition table, it can be represented using three entities The first one will tell you the new input symbol which can be replaced by the application of the previous, and then the L or R is present. This L or R is present, which basically denotes the movement of read write head, and it is basically towards left or towards right. Okay, and then we have the state. Okay, so whether it is change, if it is q2, whether it is changed to q2 to q3 or remain q2 or anything else. Okay, so this is basically the thing. And if we want to know the computation sequence for a given Turing machine, for a given input string, so we have to start from here, that first we write the initial state, and then we put the input string, and then we go one by one. And if we able to reach at the final state at the end, so definitely we can say the above input sequence is accepted by this Turing machine. Okay, so now for this 0 0, I have just shown you the first step. Now we will see the entire computation for the string 0 0 for the above mentioned Turing machine. Okay, so it is my request that if you want to uh, understand this example properly, so write this machine or then this transition table on your pen and paper, and then you can understand the subsequent steps very easily. Okay, so now I am going to explain you the next part, and which is basically the entire computation steps of 0 0 in this Turing machine. Okay, so now if you I'm doing a little bit zoom out, which can be easier for you to understand the thing. Okay, now you can see that, as I have told you earlier, here I have taken one blank symbol. You can, at the beginning, you can take it initially, or you cannot. You just proceed with 0 0, and if you require, see, if you require at the end, you can incorporate any number of blank input if it is required, and if it will be helpful to reach the final state. Okay, you can take any number of 1, 2 or 3, any number of blank input. If you want, you can incorporate it. Okay, so in my previous, what I have written in the over here, that I was not taking the blank, but in this example I am considering the blank. So you can consider this blank at the beginning. If you require, you can incorporate more blank at the end, or you can start with just 0 0 and you can incorporate the number of blanks at the end. Okay, so now we can start with this, and you can see that I am applying this 0 over here. It is 0 q1 0 b. Why? Because just I have explained you for this transition function. Now again I am applying 0 to q1, so the same thing will happen, and we are going to the same 0 0 q1. Now if I will not going to incorporate this blank at the beginning, so if you consider that this situation has occurred, so now at this state I have 0 0 q1 and no blank is present. So now at this situation we are not able to apply any kind of input upon q1. So now at this moment I am applying this rather than I am incorporating one blank symbol, one special input symbol blank to it. Okay, and now I am applying q1 a blank to q1. Okay, and now if you apply blank to q1, you can see what will happen, that this blank will be replaced by 1, and q1 will change to q2, and the movement is towards the left side. You can see the movement is towards the left side. Okay, so I think this thing is clear to all of you. It is 1, and then this left side movement, and then q1 is changed to q2. So what will happen, you can see that first, see that the movement is left side. So how to write this thing? Okay, now I am writing it here. Consider it 0 0, and then you have a q1, and for the incorporation of blank, we have this. Okay, now the movement is towards left, as we have understand through this transition function entry, transition table entry. Okay, so that means it should be come at this place as it is left side. So then put a 0, and as it is coming towards the left and this q1 changed to q2, this basically q2, so definitely we should write 0 q2. Okay, then we have to put this 0 over here. Okay, so it become 0 q2 0. Okay, and then this blank will change to q1 as per the transition entry, so this blank will change to 1. Okay, so that's why we have here this 0 q2 0 1. Okay, now we will check the next one, and that is what we have. We need to apply here this 0 upon this q2. Okay, so we need to apply this 0 upon the q2. So what will happen? Okay, so as per this transition table is present here, we know that the 0 remains 0. Okay, the 0 remain 0, and we are going towards the left, and this q2 remain q2, but the transition, the movement of the read write head is towards the left. So see how it can be represented. See, we have 0 q2 0 and a 1, and then transition function will apply. Okay, so what I am telling you, it is the movement of read write head towards the left, so definitely it should come at this position. Okay, and it remain q2, so it q2. Okay, and 0. Now another thing is this 0 is remain 0 here. Okay, so it is also a 0, and this 1 is also present, so it is q2 0 0 1. Okay, remind it, it is q2 0 0 1. Okay, so if you see our table, it is the same thing, but just I have written over here, it is q2 0 0 1. Clear? Now we should go to our next steps, and before that I am erasing these marks, and definitely I need to do some zoom out. Okay, so now you can see this, the entire problem and the solution. Okay, so what we have now, that is we need to apply a 0 upon q2. You see, we need to apply a 0 upon q2. So q2 and 0, so again it is a left movement. Now there is a question that in previously, when we are going towards the left, definitely we skip one input symbol towards the left and going towards the left. Okay, and movement of this state q is done by moving towards the left, but here is no input is present at the left of the state. So what should we do? As I have told you earlier, when we require, we able to incorporate any number of blank symbols. So here we require definitely one blank symbol. So actually what we have here q2 0 0 1, and we need to move it towards the left, but the left nothing is present. So what will happen? We have to incorporate one blank. Okay, and then movement of this q2 towards the left is happen over the blank, and then we have this 0 0 1. So clear? Now if you see these two, you can understand how this movement is done. Okay, so it is the same what you are seeing here. So when we have got this, that means now in the next condition we need to apply a blank. We need to apply a blank over the q2. Okay, So when we need to apply blank over the Q2, you can see that what will happen, blank over the Q2. Okay, this is Q2 and the blank. So blank remain blank. Okay, Q2 become Q3, Q2 become Q3, and the movement is happen towards the right. Okay, and blank remain blank. Okay, so if this thing will happen, so what we can write? See, the movement is towards the right, and as I've told you earlier, we first write the movement. Okay, so as this blank remain blank, so I'm writing this B and towards the right. So it is going towards right of the blank. Okay, so it become blank Q2, and then it is 0, 0, 1. Okay, clear? Blank Q2 and then 0, 0, 1. So definitely our next transition function will be 0 upon Q2. You can see this is done. So next will be 0 upon Q2. Okay, and let erase it. Now it is if it is 0 upon Q3, so you can see over here that this 0 upon this Q3, so 0 become blank, the movement is towards right, and Q3 is changed to Q4. I'm telling you again. Okay, now let's see what we have currently. We have a blank. Okay, and also we have a Q3, and we have 0, 0, 1. Now 0 over Q3, and 0 will be replaced by blank and movement towards right. So movement towards right means after this 0, but the 0 is changed to blank, so it become blank blank Q4, and the 0 and 1, this 0 and this one are as it is we have. Okay, clear? So this step is done. So by this way, subsequently we are approaching towards the end, and you can see that if we able to reach at Q5 at the end, and everything is pending right side of Q5, sorry, the left side of Q5, so that means we have reached the final state and no input is remain. So this state is called the halting state. I'm telling you again, by this way, subsequently, if we able to reach at a state where at the end we have a Q5, and see, we can incorporate a blank over here. That's I have done in this example, but you can see, but this blank is not unnecessary. Okay, it is not required because we have reached to the end. So by applying this process subsequently, when it is to the end, and suppose if we will not incorporate this blank, so we have this kind of thing, and where we have Q5, and after that no input symbols are present, and as this Q5 is a final state, so we can say that this 0, 0 is accepted by the Turing machine. So this is the way how a Turing machine will work. We have the transitions. I think I am able to make you understand the transition function and how it is work, and the 7 tuples of the Turing machine. Okay, so in my next video I will explain you the language acceptability by the Turing machine. Suppose we have given a language and a string, and we will check whether it is accepted or not, and if not, then what will happen. Here we have checked that which is accepted, but in my next example I will show you if that is not accepted, then what kind of situation will occur. Okay, so I think is that clear to you? Thank you for listening.